Hello everyone, I'm Vibhor Singh, and today we'll be discussing the 14th problem of the CP-31 sheet under the 1300 rated parameters. So as you can see, this is the CP-31 sheet and the 1300 rated parameter has been selected, and this is the 14th problem, array elimination. You're given an array A of length, you're given an array A1 to AN consisting of non-negative integers. Let's define define operation of elimination with integer parameter k as follows. Choose k distinct array indices 1 to I2, y1, I2, ik, whatever. Then calculate x is equal to the AND of all the k values that are chosen. And then subtract x from each of these selected values. Find all possible values of k such that it is possible to make all elements of the array equal to 0 using a finite number of elimination operations with the parameter k. It can be proven that exists at least one possible k for any array A. Okay, so let's try to understand this with this example, the first example that is given, what the problem is stating. So we have length of array as 4 and then we have 4 elements, right? Now what does it say is I have to print all possible k's such that I can perform the operation and make my array 0, some number of operations. Now what is an operation? Let's say k is 2. Okay, when k is 2, in one operation I'll choose any two indices. Let's say I choose first two indices. I will say what is the AND of these two values. 4 and 4 will give me 4. And I'll subtract this AND from these two values. So 4 minus 4 will give me 0. 4 minus 4 will again give me 0. And then I'll be left with 4 and 4. Then in the next operation, I can take the last two indices. Again, their AND would be 4. I'll subtract this and finally I'll get a 0, 0, 0, 0. Right. So with k is equal to 2, after two operations, I could get a 0, 0, 0, 0 array. Right. And finally. So 2 is one of the possible k values with which I can get all the values of the array 0 in some finite number of operations. Now similarly, if I had k equal to 4, now here if I had k equal to 4, I could choose the entire array together. Then in one operation itself, I would get that. In one operation itself, I would get all the values to be 0. And then for k equal to 1, for 1, obviously we'll be able to get all values to 0 because at once I'll choose one index. Now the AND value of a single value would just be itself, right? So 1 by 1 for each index, we'll get it to 0. So k equal to 1 is also one of the possible solutions for this. But if I try something like k equal to 3, okay, let's see what will happen. So if I try something like k equal to 3, see, let's say I chose these three elements first. Okay, I don't even need to choose elements together. Let's say I chose this, this, and this. Okay, because we can choose any elements. It's not a subarray that we're choosing. So the AND value would be 4, and then after subtracting, I would get 0, 0, 4, 0. Right. Now, irrespective of how I choose the elements, my AND value will always remain 0, right? Irrespective of how I choose the elements, my AND value will remain 0. So I can never reduce this 4 to 0. So k is equal to 3 is not possible. So the only possible values for k I have 1, 2, and 4. And then anything greater than 4 is not possible because overall number of elements in array are 4. So if I cannot put 5 because I'll never be able to choose 5 elements from an array whose length is 4, right? So that is why the only possible values of k for which I can get all values in the array 0 are 1, 2, and 4. And as we can see, that is the answer for this example, 1, 2, and 4. So I hope the problem statement is clear to you. Now let's try to understand the expected time complexity. We know 1 second in Codeforces corresponds to approximately 10 raised to 8 operations. Right. Now, we are given number of test cases as 10 raised to 4. N goes till 2 into 10 raised to 5. And it is also given that sum of n overall test cases doesn't exceed 2 into 10 raised to 5. Right. So, I can ignore the factor of t and I can just say that n extends till 2 into 10 raised to 5. And also we are given that AI goes till 2 raised to 30. Okay. So, AI goes till 2 raised to 30. Right. So, AI goes till 2 raised to 30, which is approximately of the order of 10 raised to 9. Okay. So, our expected complexity, we can look for something like order of n or order of n log of n, or something like order of n into log of a of I, also maximum of a of I, or sum of log of sum of a of I, whatever. But we cannot go anything of the sort of order of n plus a of I or order of n square, right? Because these values will be greater than 10 raised to 8, right? This would be of the order of 10 raised to 9, this would be of the order of 10 raised to 10, which will give us TLE. So I can draw a line here, I can say anything of sort of n and then any other logarithmic term is fine. But if I try to include a of I in my complexity, or if I go towards n square, then I'll get a TLE. So that's it for the expected time complexity discussion. Now let's see how we can solve this problem. Now let's look at the numbers and try to identify what are we doing in one single operation. Okay, let's say I have 2, 4, 6. I have these three numbers. Okay, let's write. First, I'll convert them into binary because I know I'm taking bitwise and in my operations, right? Okay, now let's say I have k equal to 2 right now, or I'm checking for k equal to 2. Now, what happens when I do one operation, when I do a single operation? Okay, let's say I choose this element and this element. Okay, I'll take the bitwise AND of these two values, right? That is, I will get the set bits in all the k values, right? Set bits in all k values or all k elements in the array, right? So when I choose these two elements, I'll get all the set bits in my AND. In my AND, I'll get the set bits that are set in all these values, right? So here I have only two, so I'll get only the second bit. That is, I'll get this. Only one bit is set in both the values that I've chosen. Now, after that, what I'm doing is I'm subtracting this value from this and this, right? So I'm subtracting it from each of the values I had selected initially. So I'm effectively removing the bit, right? And which bits am I removing? The ones that are set in all the k values, right? So basically, whatever values I chose, in that, whatever bit was common set in all those values, I'm effectively just removing that bit. And that is what is happening in a single operation. There's nothing else that we're doing, we're just removing whatever bit is set in all the k values. Okay, so from here, what I can get is I can solve this, or I can try to look at all the bits individually, because see how one bit will never affect another bit. Since we are taking the bitwise AND, one bit will never affect the another bit, because after, let's say over here, after performing the first operation, I'll be left with 0, 4 and 4, right? That is 0, 0, 0, 1, 0, 0 and 1, 0, 0. Now, irrespective of how I perform the operations, the second bit that was removed through the first operation will never get affected. In fact, I'll be able to only remove the third bit, that too when I choose only these two values. But no other bit, like one bit cannot affect any other bit, because we are taking the bitwise AND. So I hope you are able to understand this part. So each bit can be seen as independently. So that is the first observation we can make, that since we are removing the bits and we are removing all the set bits in the k values, that is all the bits that are set in all the k values, then we can just separate out each bit and try to understand how we'll solve it. Now, let's say I have one single bit which is set for, let's say, 3 elements, and not set, let's say it is set for 6 elements. Okay, so 1, 2, 3, 4, 5, 6. It is set for 6 elements, and then it is not set for any number of other elements that we are not cared about right now, because we are looking at this single bit and it is set in only these first 6 elements, let's say. Okay, any bit that we have. Now, what are possible k values for this one bit if I'm able to calculate that? See, for a single bit, if I'm able to calculate the possible k values, similarly for the any other bit, I can calculate the possible k values for which that bit can be made 0, right? So for each bit individually, I can calculate the k values, and whatever k values are common to all of them could be our answer. I'll get into this later, but First, let's see how I can solve for any one single bit. Any one bit. That is, I want to eliminate this one bit from my entire array. Now, let's say there are 6 values that have this bit. So, what are the possible values of k that I can have such that this 6 can be made 0? See, one I can see very clearly is there can be 6 values directly. That is, all the 6 values can be chosen together and then this bit can be removed. Right. Another way would be I could choose something like 1, right? Because one at a time I can remove it from each element. I'll choose this element first, I'll remove the bit from here because choosing an element itself, 1 will always be a possible k for any possibility of an array. That is one thing we can observe, right? Because from the number, we'll just minus itself for each index. So 1 is also one possible answer for all the values. Now, what else can be a possible value? Let's say I choose, let's see 2, 3 and 4. Okay, let's see these 3 possibilities. When I choose k is equal to 2, I can choose the numbers in pairs. That is, I'll choose these two numbers, then these two numbers, then these two numbers, right? And I can effectively remove this bit completely. And since we know each of the bits are independent of each other, I know doing this does not affect any other bits. Like it won't affect any other bits possibility. If any other bit would be possible by 2, it will still be possible by 2, k equal to 2, even if I perform these operations. Because each of the bit is independent to one another. Now, when I have 3, again I can choose in the combinations of 3, right? But what happens when I have 4? I have 6 values. When I have 4, let's say I choose these first 4 values to start with. Oh, I think I made one extra. Yeah, there's 6. First, I chose the first 4 values. Okay, now these values are 0, right? These values are 0. Or from these values, I have removed this specific bit I'm currently concerned with. And then it is set in only 2 more values now, right? Now, can I choose 4 values from here and ever get the AND value to have this particular bit as set? If for reference, let's say over here I had 2, 2, 2, 2, 2 and 2, right? Now, after the first operation, it became 4 zeros and then 2 twos. Okay. Now, is it possible to choose 4 values such that their bitwise AND is 2 so that I can eliminate these 2 twos? It is not possible, right? So, from here, what do I get? I get that any value that divides the number of occurrences of the bit, that can be a possible k value. But any value that does not divide cannot be a possible occurrence of k. Okay. So, if a bit is set 6 times, all the factors of 6, that is 1, 2, 3 and 6, they are the possible values of k. But values such as 4 and 5 are not. And this is very intuitive to understand as well, right? Because in one operation, what are we doing? We're selecting a particular number of values and we're removing that bit from those values. And note, if there's any extra element which does not have that bit set, then automatically we'll not remove that bit, right? Let's say this instead of 2 over here. Okay. If over here instead of 2, I had a 4, then choosing these 4 elements together would not help me because 2 would not be set. If 2 is not set here, 2 will not be set in the AND of all these values. So I will not remove 2 from this entire set, right? So that is why it is very easy, simple to understand that yes, we can only form k such that k is a factor of the number of occurrences of a single bit. Now, we need this over all bits, right? So can I say that whatever value k has, it should divide the number of occurrences of each of the bit. K should divide number of occurrences of each bit. So number of times each bit occurs in the entire array combined, that value should be divided by k. Each of the bit should be divisible by k So this is what we get, and should be our final and sufficient condition, right? But now you'll say, oh, still we'll have to, how do we iterate over all k, because a of I can go till 10 raised to 9, right? So I cannot just iterate over all k, right? I cannot just iterate over all k and then let's say I counted all the occurrences of the bits. That is, let's say 2 raised to 0 is set 4 times, 2 raised to 1 is set 4 times, 2 raised to 2 is set 3 times, something like this. I got the frequency map or the number of occurrences of each bit in the entire array combined, or number of elements for which that particular bit is set. Okay. Now I cannot run k till 10 raised to 9 and check it, right? But I don't need to run k till 10 raised to 9, right? First thing is, the number of elements in the array are only 10 raised to 5. So I can also run over k because this is a frequency map, right? But an even more efficient solution would be that I know that what is a value that divides all the values. Like I have a set of values and I want to find a value that divides all these values. Okay. The first thing that comes into the mind is the GCD of these values, right? The GCD will divide all the frequency. So GCD of all frequencies. The GCD will divide all the frequencies, right? Then with GCD we'll get one of the k values, right? After that, how do I get all the other values? Well, whatever the GCD is, all factors of GCD are possible k. Now, why does this come? See, let's try to understand. Let's say I have 12, 6, 18 and 24. Okay. These are the number of times these particular bits occur in our array. Okay. So we simplified the first part. We counted the occurrence of each of the bits. So 2 raised to 0 is set 12 times, 2 raised to 1 is set 6 times, so on and so forth. Then I'm calculating GCD of these values would be 6, right? And since GCD divides all these values, all factors of the GCD will divide all these values. That is 1, 2, 3 and 6. All these values will divide each of the values in this array, right? So this set of all factors of the GCD will be my answer, right? Because any value that does not divide the GCD or any value greater than GCD, let's say I just try with 12, then this bit will not work because it is smaller, right? And any value that does not divide GCD, such as 4 and 5, they will not divide all these values because GCD is the largest value that we have gotten, which will divide all these values, and all factors of GCD will also divide all these values. So from here I can get that k is, or all possible values of k, the set would be all factors of GCDs of the number of times, or the GCD of the number of elements a bit is set in. So number of elements a bit is set in, this thing will be calculated independently for each of the elements, and then we'll take the GCD of all those numbers, that is all the frequencies, and then all the factors of this GCD will be our final answer. So I hope you were able to understand the solution of the problem. Let's move on to the code. So first we take the number of test cases as input, then for each test case we are taking n as input and we are taking the array as input. I have not created an array because I am only concerned with the frequency of occurrences of each bit. So for which I have created a frequency map of int comma int, and then I'm taking temp as an input, as a temporary input, and then for each bit from 0 to 30 I'm doing if temp and 1 raised to 1 bitwise left j. This is a way of checking whether the jth bit is set in a particular number then I'm increasing the frequency of that bit if it is set in a particular number. Note I've gone only till 31 because of the constraint given to us that a of I goes to 2 raised to 30. So j less than 31 should be sufficient. Then I have initialized answer as 0. Basically, answer is the GCD value that I'm getting over here. Okay. Or yeah, it is the GCD value. I have taken f as 1. Why have I taken f as 1? Let's come to that later on. So this is a flag variable. Basically, it's to handle case like this over here that we have 5 and then 5 zeros, for which the expected output should be 1, 2, 3, 4 and 5. Right? All the values are already 0. Our overall solution doesn't really handle this case too well. So that is why, see, when we have all the values as 0, our map will be completely empty. Right? Because for none of the values will a bit be set. Right? All bits are unset for 0. Right? So if all values are 0, our map would be empty. So we will never enter this for loop. Right? And as soon as we enter this for loop, I'm making flag as 0. So if flag is set, that means all values in our answer are 0 or all values in our given array are 0. So that is why if flag is set, then I'm just printing all values from 1 to n. So I'm printing all the values from 1 to n. If my flag is set, that is all values in my array are 0. So that is the purpose of this variable. F is equal to 0. This is a flag variable. Now for the frequency map, for each frequency, first thing I'm doing is, if that is initially I initialize answer as 0. So if it is 0, I'll just make it to the current frequency, right? Since I want to calculate the GCD, it is very tricky to initially initialize the answer, right? I want to calculate GCD values. It can get very tricky. What should I initialize as my default value for it? That's why I've made it 0. And whenever I get the first value in the map, I'm just putting answer to be my first value in the map, right? Or a better naming for this I can use is, let's call this GCD. Okay. So then if GCD is not 0, note that while taking GCD, while calculating GCD, our value can never become 0. It will, in the worst case, also become only 1. So that is why I know only initially this will happen. It will never happen again because our value can, at the worst case, become 1. So in the else part, I'm just taking the GCD with the frequency. That is I dot second. And then after that, if there's a flag thing, then obviously, as we discussed, for all zeros, we are printing all numbers from 1 to n and we are doing continue. That is, we are ending the execution of the current test case because we are in a while loop for each test case. And then in the end, I'm calculating the factors. That is the general method, I starting from 1, I into I less than equal to the variable that I have renamed as GCD now. Then I plus plus, and then if our GCD value is divisible by I, in the factor I'm pushing back I, and if it is not the exact square root of the GCD, then I'm pushing back GCD by I as well. So this is in root of n when we calculate factors. This is the very common methodology for that purpose. And then in the end, I'm sorting factors and then printing it. So we have to print the factors in a sorted manner in our solution, or we have to print k in the sorted manner. That is why I'm sorting the factors and then I'm printing f in the end. So that's it for the solution discussion. Now let's see the time complexity of this solution. So this loop runs in, you can say it runs in order of n into log of a of I, since I am running 30 times and 30 is basically log of a of I, right? So this runs in order of n log a of I, right? Although a of I doesn't make too much sense because we have not taken a as an input over here, but understanding from the problem perspective, it is log of a of I, right? Or log ai, n log ai. You can just take n log ai, whatever, however you want to call it. And then this running of the map. Now, see, number of values in our map can be only 30, right? Number of values can be only 30. And for each value, I'm calculating the GCD. Now, GCD would again run in order of log n, right? And, okay, the number of values in the map would be 30 because there are only 30 set bits possible, right? So that is the I dot first part, right? That is the key of the map. There can be only 30 keys. Now for the values, that is I dot second, what is the maximum value I dot second can go to? it can go till 2 into 10 raised to 5, that is n, right? I dot second can go max till n because one bit can be set in maximum all the values, right? If a bit is set in all the values, then the frequency of that bit would become n. So I dot second can maximum go till n. So overall complexity of this loop will just become log of a of I, that is basically 30 times log of a of I into log of n, right? So I can do log of a of I into log of n like this. This would be the complexity of running this loop. And in the end, when we are printing for this, it will be log of n simple. Oh, sorry, order of n simply because we're just printing values over here. And at the end, for calculating factors, this will run in the worst case order of square root of the GCD value, and the GCD value in the worst case can go till n. So this will run in maximum square root of n in the worst case, right? And then finally printing the answer will again be order of n. So overall time complexity, if we add all these values, the highest would be n log of a of I. So the overall time complexity of our solution will just become n log of a of I, something like this, right? And for the space complexity, we are getting, see, we did not take array as our input. The map will have maximum log a of I number of elements, and then our GCD entire calculation also runs in constant space. We are not creating any array or something. Our factors uh, vector that we'll have will also have maximum like number of factors a number can have. There is a proof of somewhat of some sort that it can go till maximum, I think, cube root of n, but it's not a very significant number. So overall space complexity in the worst case can go of the order of log of a of I plus cube root of n. So I think that is the worst case space complexity of this solution. So that's it for the space and time complexity discussion. Hope you were able to understand the solution. Thank you.